Good day, everyone. I'm Sir RJ Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about graphing linear inequalities in two variables. So last time, we've already discussed all about illustrating linear inequalities in two variables, and we've already differentiate what are the symbols of linear equation and difference between linear inequality, right? Now, for this lesson, I will present what are the steps in graphing linear inequalities in two variables, and we will have several examples for this lesson. So step number one, we need to rewrite the inequality as an equation and solve for the intercepts. After you solve the intercepts, you may now plot and draw the boundary line. You use solid line if the inequality is either greater than or equal or less than or equal, and broken line if the inequality is less than or greater than. Okay, step number three, we need to decide which half plane contains the solution set. Pick a test point that is on one side of the boundary line. You can use 0, 0 or the origin if possible, and then replace x and y in the inequality with coordinates of that point. And if the resulting inequality is true, shade the side that contains the test point. If the resulting inequality is false, shade the other side of the boundary. For us to know which boundary is which side of the boundary is true, you can pick three test point for this one. We will use the origin 0, 0 and then two test point from both sides of the boundary line. So for example number one, we need to graph the given linear inequality 3x plus 4y less than 15. So step number one, we need to change the linear inequality into linear equation. So we have now 3x plus 4y equals 15. Next, we need to find the intercept. So we let x is equals to 0. Substitute 0, x is equals to 0 under a given equation now. We have 3 times 0 plus 4y equals 15. And then since we have 4y now, so 3 times 0 is 0 plus 4y, we have 4y equals 15. Divide both sides by 4 so that we have now y is equals to 15 over 4 or y is equals to 3.75. For x-intercept, we will now let y equals to 0. So substitute y to the given linear equation. So we have now 3x plus 4 times 0 equals to 15. So we have now 3x plus 0. So we have 3x equals to 15. Divide both sides by 3. So we have x is equals to 15 divided 3 is 5. Step number 2, we can now plot and draw the boundary line. So we will use the given point of y-intercept and x-intercept. So since we have, if our x is 0, we will get y as 3.75. And if our y is 0, we will get x is equals to 5. Now we have the boundary line for this one. So we will use broken line for this one, class. So let's change this. Let's just change this one later. So we will use broken line for this given question since our inequality is less than. Again, if less than or greater than, you will use broken line. So let's just change that one later when we shade the region. So pick a test point that is on side of the boundary line. Use 0, 0 if possible. So we have, now we will use 0, 0 so substitute to our given inequality. So we have 3 times 0 plus 4 times 0 is less than 15. So we have 0 plus 0 is 0. Is 0 less than 15? That is true. Next, if we will test a point from this side of our boundary line. So we have here 5 and 6. So we have here. So substitute to our given inequality, we have 3 times 5 plus 4 times 6 less than 15. So 3 times 5, we have 15. And then 4 times 6, we have 24, less than 15. So 15 plus 24 less than 15, so we have 39. Is 39 less than 15? False. No, of course not. So that is a false uh, statement. Next, we have here, we need to plot, we need to pick another point from this side of the boundary line. So we will use -2 and -2. So substitute -2 and -2 to the given linear inequality. So we have here 3 times -2 plus 4 times -2 less than 15. So we have now 3 times -2, we have -6. 4 times -2, we have -8 less than 15. So -6 minus 8. So we have -14 less than 15. Is -14 less than 15? Yes, that is true. So now we can now plot this one using the given points which are true. So we have here the broken line now, and our intercepts here is plot along the borderline, and the 0 point here, which is in the shaded region. Now you will now shade the region which are the points results are true. So 0, 0, and -2 and -2 is true. So we need to shade that region. And then leave the other side not shaded. So since 5 and 6, we've already solved the 5 and 0.5 and 6, the result is false. So that means that is not a solution for our given linear inequality. Example number 2, we need to graph the given linear inequality. We have y less than or equal to 7x plus 21. For us to solve easily, no, we will transform the y as a slope-intercept form into standard form. So we will now have transpose 7x in the left side. We have -7x plus y less than or equal to 21. And in step number 1, what is step number 1? We need to rewrite the given linear inequality into linear equation. So -7x plus y equals to 21. Then find the intercepts. If x is equal to 0, so we have -7 times 0 plus y equals to 21. So -7 times 0, we have 0 plus y. We have y equals to 21. And then if y is equals to 0, so we have -7x plus 0 equals to 21. -7x equals to 21, divide both sides by -7. So we have now x is equals to 21 divide -7 is -3. So we can now plot and draw the boundary line. We will use, no, if our x is 0, our y is 21. Now, if our y is 0, our x is -3. That is the points in your intercepts class. So, what will you use here? Solid line or broken line? Since our inequality is less than or equal, so we will use a solid line. Then connect the points there. And then after that, we will need to pick a test point that is on one side of the boundary line. We will pick 3. Use the origin and then pick 2 different points from the other side of the boundary. So we will use first 0 and 0. Substitute that one in our given linear inequality. We have -7 x plus y less than or equal to 21. So substitute 0, 0. So we have -7 times 0 plus 0 is less than or equal to 21. And then now, 0 plus 0 is 0. Is 0 less than or equal to 15? That is true. Next, we will pick points here. So we will use in this side. So -5 and -2. Where is -5 and -2? Here. This is -5 and -2 there. So substitute, we have -7 times -5 plus -2 less than or equal to 21. So we have negative 7 times negative 5, we have 35, minus 21 less than 15. So 35 minus 2, we have 33 less than or equal to 15. Is 33 less than or equal to 15? No, so that is false. Next, we need to pick another point from this side. So we will use 4 and 3. So we have 4 and 3 here. So this one. This is the point here. So this side na. So substitute to our given linear inequality. So we have negative 7 times 4 plus 3 less than or equal to 21. So now we have negative 7 times 4. We have negative 28 plus 3 less than or equal to 15. So negative 28 plus 3, we have negative 25 less than or equal. Is negative 25 less than or equal to 15? Yes, so that is true. So which points now are true? No, which part of the boundary line? So this side. So we just need to shade this side, since this side, all points here are true when we substitute to our given inequality. Last example, we have 3x minus y greater than negative 5. So now, step number 1, we need to rewrite it to linear equation. So we have 3x minus y equals to negative 5. And then substitute find the intercepts. If x is equals to 0, so we have now 3 times 0 minus y is equals to negative 5. So our negative y, so 0 minus y, so we have negative y equals to negative 5. Divide both sides by negative 1 so that we will have a positive y. So y is equals to positive 5. And if y is equals to 0, so substitute to our given linear equation, 3x minus 0 is equals to negative 5. So 3x minus negative 5, so divide both sides by 3. So we have x is equals to negative 5 over 3, or negative 1.67. Plot and draw the boundary line. So we will now use the points. If your x is 0, your y is 5. And if your y is 0, your x is negative 1.67. So we have now here. So we will use here broken line, ha. So later on, or in our final graph, no, the result is getting broken line. So connect the points here. And then we need to pick the test point. So first we will use the origin 0, 0 if it will come true. So substitute, go back to your linear inequality. So substitute 0, 0 there. So we have 3 times 0 minus 0 greater than negative 5. Is 0 greater than negative 5? That is true. And then we need to pick another test point here from this side. So we will use 2 and negative 2. So we have 3 times negative 2 plus negative 2 greater than negative 5. So we have 6 minus 2 greater than negative 5. So 6 minus 2 is 4. Is 4 greater than negative 5? That is true. And then next, pick another point from this side. So we will use negative 2 and 6. So we have here 6. So negative 2 and 6. And then next, now, substitute here. So we have 3 times negative 2 minus 6 greater than negative 5. So 3 times negative 2 is negative 6 minus 6 greater than negative 5. Negative 6 minus 6, we have negative 12. Is negative 12 greater than negative 5? So no, that is false. So we can now, we have here the broken line, as our, in step number 2, since our inequality is greater than, so we will use broken line. So since the points where 0, 0, and negative 2 lies on in this boundary, so we need to shade this boundary. So that means all of this solution or all of this shaded region, when you substitute that one into your linear inequality, it will result to true. And then this one, the false point, so negative 2 and 6. I hope that you've learned something out of this lesson. Please don't forget to like and subscribe and share it with your grade 8 friends and classmates. That's all for today. Goodbye.